Today we're going to be rewriting equations and formulas. It's going to be tempting to take a shortcut. I'm not going to let you take the shortcut. So in example 1, it says solve for y, then substitute the given value of x into the equation. Some of you would be tempted right now to plug 1 into x and then solve for y. I don't know why my screen keeps jumping around. I might have to throw this computer through the window that I do not have, which means through a cement wall, which would be even more satisfying, I think. All right, we are not allowed yet to plug the 1 in place of the x because it says solve for y. So the first thing that we have to do is get y on a side by itself. And we are really just using your skills from Algebra 1 for rearranging an equation. If I want to get y by itself, y is currently inside the term negative 7y, so I need to get that by itself. How do I move the 5x to the other side of the equation? Subtract it. So I'm going to subtract 5x on both sides. Am I allowed to combine negative 5x and 21? No, they are not like terms. So we have negative 5x and positive 21. What should I do now? Divide by negative 7. And some of you have gotten into the habit of just doing one big division thing under the entire right side. I'm going to encourage you to divide every single term by negative 7. It will help you to fully simplify your result. So our simplified equation is y equals positive 5/7 x minus 3. This is the most simplified, best version of this equation. Now we are allowed to substitute that 1 in place of our x. So y equals 5/7 times 1 minus 3. You can grab your calculator and beep, bop, boop to get that answer. You get the decimal negative 2.286. Or if you prefer to change that to a fraction to make it look a little bit nicer, it's negative 16/7. Number 2 is basically exactly the same. It's just written a little bit differently. Instead of being in standard form, it's got the x on one side and the y and the constant on the other. So try number 2 on your own, and then we will do number 3 together. We would add 24 to both sides, and then divide everything by 3. If you want to leave it as negative x over 3, I won't count that wrong, but I like to write it as negative 1/3 x. I think it looks a little cleaner, but if you want to write it as negative x over 3, that is fine. When we plug 9 in, when we substitute 9 in place of the x, did you get y equals 5? All right. Number 3, there are 2 ways to do this. One way involves factoring, but honestly, the other way is easier, so we'll go with the other way. Our first option is we need to get the y by itself. The y is in this term. So the first thing that we need to do is move the 3x to the other side. So we have negative xy equals negative 3x plus 8. We subtracted 3x on both sides. What should we do now? divide by negative x. And that might seem a little bit weird, but it's totally allowable. That gives us y equals negative over negative is going to result in positive, and the x's cancel, so we just have positive 3. And in the next term, it's just better to not put a negative on the bottom, so this is minus 8 over x, or plus a negative 8 over x. You can write the negative between the two terms, or you can put it in the numerator, but you shouldn't leave a negative in the denominator. And it might look really weird to have x in the denominator, but that is fine. That's how this equation is. When we substitute 4 in place of the x, this one should be pretty easy to do. 8 divided by 4 is 2. 3 minus 4, or 3 minus 2 is 1. Solve the formula for the indicated variable. Whatever they say solve for, that's the thing that you're trying to get by itself. So solve for r squared, we need to get r squared on one side of the equation by itself. The first thing I notice is that we've got 1/3, and I want to get rid of 1/3. Does anyone remember how we should get rid of that 1/3? Multiply by 3. So I'm going to write a little note to myself up here to cancel a fraction, multiply by the reciprocal. So when we multiply by 3, we'll have 3v on the left, and we will have pi r squared h on the right. Okay, this might sound like a trick question. I promise it's not. What's happening between the pi, the r squared, and the h? What operation exists there? Multiplication. And to undo multiplication, we use division. So we are going to divide by all of the stuff that we don't want. We don't want pi over there anymore. We don't want h over there anymore. So our r squared is going to equal 3v over pi h. Try number 7 on your own. We'll do number 6 together in a second. So I equals PRT. We want to solve for r. We're going to divide both sides by PT. So r is going to equal I over PT. Hopefully that one was crazy easy. Number 6. What's a little bit difficult is that the thing that we are trying to solve for is currently stuck inside the parentheses. So our first goal is going to be get the parentheses by themselves, then we can get that b1 by itself. So how should we get rid of the 1/2? Multiply by 2. So 2a equals b1 plus b2, that whole thing times h. What do you think we should do next? Divide by h. And I'm going to go ahead and switch my equation around so that my bases are on the left side. Remember, it doesn't matter if you write the left side on the right or on the left, as long as you flip the whole thing. Now that the parentheses are by themselves, do I need the parentheses anymore? No, so now we can erase those parentheses, hopefully without erasing what the actual letters are. We're trying to get b1 by itself, so how do we get rid of that b2? We subtract b2. So b1 equals 2a over h. minus B2. B2 was not divided by H. Only the 2A is being divided by H. So make sure that that B2 is separate and not on top of that H.